Okay, so now let's see. So in level 100, we looked at this. Okay, so maybe you have some points like this, right? And then what do? Oh, I have to be doing this work. What can you say about this from your knowledge in 111? Yes. What can you say? I hope you can see my screen.
Yeah.
Please, do you see the screen?
Yes, sir.
Good. What can you say about the relationship between Y and X?
Yeah,
There's a positive
Let's say Y is with
positively correlated.
X is, let's say, age. What can you say?
There's a direct relationship between with.
What do you mean by direct?
Like maybe a strong relationship
What do you mean
between
strong?
with age.
What do you mean by strong?
I mean, like there's a positive relationship between weight and age.
And what do you mean by positive?
Like any occurrence on X affects an occurrence on Y.
There's what? Yes, Mavis, you can unmute yourself, or I have to unmute you.
There you can see
Yes,
that they are positively related, and then they are closely related. That's because when you draw a line to so I hope you understand. But yes, you can see that. But when you draw a line, you can see that they are closely related. They are not far apart from each other.
They are closely related. Okay, please, but you need to explain more for us to know exactly what you mean.
So you see, when you draw a line,
yes.
When you draw the line, you can see that they are not far apart from each other.
Okay.
Yes, so this means that they are strongly related, and it's a positive relationship they have.
Okay. Yes. Who else? So this is how you explain to your younger sister or brother at primary 5. How are you going to explain this to the person?
Sir.
Yes, iPhone user who wants to show us that he's using iPhone.
Say. Say.
Yes, iPhone, we are listening to you. Please carry on.
Please, there's a positive relationship between weight and age.
What is the positive?
As weight increase, as age increases, weight is also increasing.
Yes, now that you are explaining it better. So if you say positive, I mean, it will be difficult for somebody to understand. But literally, what it means is that as the person's or animal or whatever's age increases, you expect the weight of the person to also increase. Is everybody okay with this?
Yes,
Good.
please.
So here, what we are saying is that we may be interested in knowing the weight. So I go to the, you see the children or the kids, while they are born, they go to what they call weighing, or is it, the ladies should help us, is it postnatal or whatever it is. Yeah, but if you go the community nursing people, they will weigh the child and plot some graphs and see whether the child is growing well or not, or they should give some intervention as to, let's say, food, nutrition. Some will be getting too big, okay, so overweight. So it means you need a dietitian to reduce maybe the protein the person is taking in and so forth. Some will be also malnourished. They will be given other foods to boost their nutritional levels. Okay. So now there, if you go to the way, who has accompanied his or her parents to that, what I'm talking about? Legon Hospital, when you go, they are there, close to the maternity ward. If you go to Mom, they will be there, 37, everywhere, almost every hospital, they do this. Okay. Now, if you go there, once they hold your card, they will be able to know your age, right? Or the child's age. However, for the weight, they need to actually put the child in that sack, okay, and weigh the child. Okay. So basically, in correlation, all you say is that, okay, if the person's age is increasing, I expect the person's weight to increase. That's all it will give you. But in regression, what we are doing is an added one that, okay, we are interested in weight. As for the age, as soon as you come to the hospital, we know your age because we have records of you. But your weight, we need to what? We need to put you in a sack to know it. So what if you do not bring the sack? What do we do? During COVID time, nobody will allow you to use the sack that you use for your child on the person's child. So it means that if you are not there, we need to estimate your weight. What do we do? That's where regression comes in. Okay, so we take your weight as a function of what? Your age. So what do we do? Essentially, what we are trying to do is to get what? A model of this form. Y is equal to some beta naught plus beta 1 x plus what? Epsilon. Now, we are saying that beta naught, these ones, they are not different from what you know from your SHS. iPhone, your hand is still on. Do you want to ask a question? If not, lower your hand. Okay, good. Now, what we are saying is that this line is not different from what you know as y is equal to ms plus c. The only addition here is what? Epsilon. And it is so because if we go to that weighing hospital, okay, we can take two, let's say this is, I think they do it up to 6 years or so. So we can say 0, maybe 1, 2, 3, 4, 5, 6. So if we take 2 people here, they are of the same age, but one's weight is this, the other's weight is that one. So this person weighs more than that one, right? Is everybody okay? This one weighs, if I'm using the circle, this will be heavier than the other one. Okay. Why is it so? It is so because there's some sort of variability, and that variability is what this one is providing. Right? So to be able to help us to do so, we say, why? We've learned distributions in 1, 1, 2. So what we are going to do is that we put a distribution on this. This should have a normal distribution with mean 0 and variance sigma squared. Okay. Now, what does this mean? It means that my yi's are random because it consists of some what? Deterministic part, which is what? The beta naught plus beta 1x, okay? Which is your C plus MS. You usually will use what? MS plus C from SHS. Right. So that's it with it. Then we have, so this is deterministic. Why is it deterministic? Because I can find my beta naught and beta 1. Okay. And then once you give me the age, I know the weight. That's it. Okay. So that's it. So in regression, our aim is to what? Estimate this beta naught and beta 1. Now, so what does this, what are the assumptions? We talked about the assumptions, okay, that the errors are normally distributed, they are uncorrelated, right? They have a constant variance, right? Variance of y is that we can find the expectation of y is equal to beta naught beta 1x. We've done this in class and I've also done this. So I expect you to know what this is. Okay. Next. Oh, no. Erase it. Okay. Now, let's see. Now I want to move on to, so the question is, how do I find the y, my model? So we said that our we have our model y is equal to beta naught beta 1x plus epsilon, right? This is beta naught. Okay. Now, what we are going to do is that at the end of the day, we want to be able to find y cap is equal to what? Beta naught cap plus what? Beta 1 cap x. Now, how do we do so? We said we use what? The least squares. The least squares method. What is the least squares principle? What is the least squares principle? It is that we want to minimize the error between our y, the original one, and this y cap, right? And I said that we square this such that what? We do not get 0. Okay. So if we do this, we can substitute this in, which is that one over here. If we do so, then we can now do XSE against delta beta naught. We set it to 0. We do SSE, okay, delta beta 1. We set it to what? 0. We get our normal equations. People are they asking questions? Why are some of you showing your face? Can't you close? Okay, good. Okay, please make sure you don't turn the chat room into because I'll have to, it will distract me. Now I would have continued. Now I have to go and read. So please make sure whatever you are typing there is related to what we are doing. Okay. Now, so we found out that from this, we can actually get the estimates, and the estimates we got were what? Beta cap 1 is equal to n sigma xy minus sigma x sigma y. Unfortunately, we are not giving you this because you are not psychology nor sociology student. So you should know it. If you go to sociology department, psychology, when you are doing psychostat, they will give you this one. beta 1. X bar. So that's how we find this. Okay. Okay. So then we got an example. So as an example, we took, can you provide me with the example we did?
Okay.
It was on what cost, right?
So please, I have a question.
Isn't it? It was cost and what? Cost and
Service was cost and the
mileage.
mileage of the road.
The road, yeah. So cost, we have something like that. What were the values? Quickly. Or let me take any value if you are not providing it. So this is cost, let's say in millions. Okay. So we have 2 million, maybe this thing is 10. We have mileage of 20, the cost is 5. Then we have mileage of 6, the cost was 3. Mileage of maybe 5, but the cost is 10. And the mileage of, let's say 4, the cost is 12. Okay, so something like this. Okay, so let's say you are the Roads and Highways Ministries. You have this data. So what we can do a scatter plot. Have you done what I said you should do? So this will be cost against what? Miles. Something like that. Okay. So the mileage we have 4 to 20. So maybe 5, 10, 15, 20. Okay. Then over here we have up to 12. So maybe 2, 4, 6, 8, 10, and maybe 12, something like that. So we take 2 and 10. So 2 will be somewhere here, 10 there. 2, 5 and 25 and, oh, sorry, 20 and 5. So somewhere here. Okay. The next one is what? 6 and 3. 6 will be somewhere here and 3 somewhere here. The next one is what? 5 and 10. So let's see. Oh, I think I'm confusing myself, right? The other one was, it's supposed to be the other way around and nobody corrected me. Okay. So that one is not, this one was wrong. Then is everything wrong? The 5 and 10 will be this.
So the 2 and 10 is also wrong.
The 2 and 10, right? 2 should be here. And then 10 should be, okay, let me start again. Okay. So the first one, we have what? We have a 10 on the mileage. So we are here and then 2. So here, right? This is right. Then 20 and what? 5. Somewhere here. Okay. And then 6. Somewhere here. 6 and 3. So there. And then which one again? 5 and what? 10. And then 4 and what? 12. Okay. So we have something like this. Okay. So
The 6 and 3 is wrong.
which one?
The 6 and 3.
6 and 3.
Yes, it's supposed to be between the 5 and the 10. But you sent it to the 20.
The 6 and 3
Okay.
is 1. Is it not somewhere here?
Yes,
Yeah.
it's between the 5 and the 10.
Which one?
I mean the x-axis.
The x-axis is 6, isn't it?
Yeah, and
Yeah.
the y-axis is 3. So when you plot it, it's supposed to be between the 5 and the 10.
10. Yeah, but that's what I did over here, or it's not that one. This,
That's it.
Oh, okay, yes.
yeah.
Thank you.
Don't let us, I mean, this is just plot. So even if we made a mistake, let's just move on. Okay. But essentially, if you have something like this, then if we are drawing a line, it will be somewhere here, right? Something like that. So that's the sort of thing we want to do. Okay. So how do you do this? Well, your X and Y, we know our X and Y. So you can just start with X, Y. I'm not going to do all this. Okay. So your X, you have 10, 26, 5, 4, right? And then over here you have what? 2, 5, 3, 10, 12. Is that not it? So you need XY. So you can multiply X and Y. What do you need again? You need X squared. You can get X squared, right? So this one will be 20. This one is what? 100. This one is what? 18. This one is what? 50. This one is what? 48, right? Like that. Okay. Then you get the sums. So this one is what? Sigma X. This one is sigma Y. This one is sigma XY. This one is what? Sigma S squared. Once you get this, you need, or you have all of them. N is equal to what? 5. You plugged it into this, you have your values. Beta naught and beta 1. Now, the next question was, how do you interpret what? Beta 1 and beta naught, right? So if you compute this, you should get your beta naught cap. Let's assume that beta naught cap is 2.4 and beta 1 is, in this case, the way the graph is will be negative. So let's say negative 1.5. Now, how do we interpret this? I'm not saying this is the answer. Okay, you need to what? You need to work it out and then you can get the answer, okay? Please, but I'm just using this just so that we move on quickly. Mackenzie, please, you can ask your question. You've raised up your hand, so please go ahead, ask your question. Okay, it doesn't seem he's talking, so let's move. I think it will go up, but we'll have to join again, okay? Yeah, okay. So here, what we are saying is that if the mileage is 0, that is, it's like the basic cost of the construction of the road is 2.4 million. That is beta naught. Then beta 1, because it is negative, we'll say that for any additional 1 mile increase in what? In mileage,